Hey, science fans, let's talk about uranium. When you hear that word, what comes to mind? Giant explosions, glowing green goo? It's true, uranium has a bit of an image problem. Many people only associate it with nuclear weapons and dangerous power plants, but there's so much more to this element than its explosive reputation. Uranium is often misunderstood. It's true that uranium is used in nuclear technology. This is because it's radioactive. But radioactivity doesn't automatically equal danger. It's all about understanding how it works and using it responsibly. Just like fire, uranium can be dangerous if mishandled. But it can also be incredibly useful when used properly. Think of it like this. Fire can burn down your house, but it can also cook your food and keep you warm. The same goes for uranium. It's a powerful element with a wide range of applications. We're going to explore those uses together. We'll see how uranium isn't just about bombs and power plants. Get ready to have your perceptions challenged. We're about to unlock the mysteries of uranium and discover its hidden potential. Let's start by busting a myth. Many people think uranium is incredibly rare. They picture scientists searching high and low for tiny traces of this elusive element. But guess what? Uranium is actually more common than silver, gold, or even mercury. That's right, it's everywhere. Uranium is found in rocks, soil, and even seawater. It's literally all around us. In fact, the Earth's crust contains about 10 trillion tons of uranium. That's heavier than 100 billion Statues of Liberty combined. It's not concentrated in one place, though. It's spread out, kind of like sprinkles on a cupcake. You might be wondering, if it's so common, why don't we see it everywhere? Well, it's all about concentration. Think about sugar in your coffee. You can taste the sweetness even though the sugar has dissolved and spread throughout the drink. It's similar with uranium. It's present in our environment, but usually in very small amounts. So, the next time you take a walk outside, remember you're walking on a planet teeming with uranium. Now that's pretty cool, isn't it? Now, let's dive into the heart of uranium's uniqueness, its physical properties. One of the most fascinating things about this element is its ability to change its form. You see, uranium can exist in two different states, alpha uranium and gamma uranium. It's like having a superhero with a secret identity. Alpha uranium is stable at room temperature. It's the form most commonly found in nature. Think of it as Clark Kent, mild-mannered and unassuming. But when you heat uranium up to a scorching 1,235 degrees Fahrenheit, it undergoes a dramatic transformation. It becomes gamma uranium. Gamma uranium is like Superman strong, powerful, and full of energy. This form is crucial for nuclear applications, as it allows for a controlled chain reaction. This reaction is what makes uranium such a potent energy source. But the fun doesn't stop there. Gamma uranium has another trick up its sleeve. It can conduct electricity with almost zero resistance at extremely low temperatures. This phenomenon, known as superconductivity, opens up a whole new world of possibilities in electronics and energy transmission. We'll explore that more in a bit. Remember how we talked about gamma uranium's superpower, superconductivity? Let's delve deeper into this incredible phenomenon. Imagine a world where electricity flows freely without any loss of energy. That's the promise of superconductivity. When cooled down to extremely low temperatures, gamma uranium becomes a superconductor. It's like turning a bumpy dirt road into a super smooth highway for electrons to zip through. In this state, uranium can conduct electricity with virtually no resistance. This means no energy is lost as heat, making it incredibly efficient. Think about it. Our current power grids lose a significant amount of energy as heat during transmission, but with superconducting materials like gamma uranium, we could potentially revolutionize the way we transmit and store energy. We could create super-efficient power grids, high-speed trains that levitate on magnets, and even incredibly powerful computers. Uranium's superconductivity is still being studied, but it has the potential to unlock groundbreaking technologies. It's like having a key to a room full of scientific treasures just waiting to be discovered. Section 5. Beyond the bomb uranium in everyday tech. Let's explore some everyday applications of uranium. This element isn't just confined to nuclear reactors and labs. It's closer to home than you think. Remember those old-fashioned glow-in-the-dark watches? They used to contain a tiny amount of uranium. Uranium is also used in some types of smoke detectors. And here's a surprising one. Uranium is used to color glass and ceramics. These are just a few examples of how uranium is woven into our daily lives. Section 6. Medical Marvels, Uranium's Healing Touch. Hold on to your lab coats because we're about to enter the world of medicine. Believe it or not, uranium plays a vital role in healthcare. This element, often associated with harm, can actually be harnessed for healing. One of the most important medical applications of uranium is in radiation therapy. This treatment uses high-energy radiation to kill cancer cells and shrink tumors. Uranium-238 is a common source for producing medical isotopes like cobalt-60. Depleted uranium, a byproduct of uranium enrichment, is incredibly dense. This density makes it ideal for use in medical equipment such as radiation shielding. It's like a lead apron on steroids, protecting patients and medical professionals from harmful radiation exposure. So the next time you hear the word uranium, remember its life-saving potential. Section 7. Dating the distant past. Uranium's time-traveling tales. Get ready for a journey through time because uranium is also a master chronologist. It's like having a time machine that allows us to peek into the distant past. Uranium-238 decays into lead over billions of years at a predictable rate. Scientists use this decay process known as radiometric dating to determine the age of rocks and fossils. By measuring the ratio of uranium-238 to lead-206, they can calculate the sample's age. Radiometric dating has revolutionized our understanding of Earth's history. Uranium is a key to unlocking the secrets of the past. Section 8. Powering the future. Uranium's clean energy potential. Let's face it, folks, we need clean energy, and we need it fast. And guess what? Uranium just might be a key player in the quest for a sustainable future. It's time to move past the misconceptions and explore its potential as a clean energy source. Nuclear power, which relies on uranium, is a low-carbon energy source. Unlike fossil fuels, nuclear power plants don't produce greenhouse gases during operation. This means less pollution and a healthier planet for all of us. But that's not all. Scientists are hard at work developing next-generation nuclear technologies, such as small modular reactors and thorium reactors, that offer even greater efficiency and safety. These advancements could revolutionize the way we generate electricity and reduce our reliance on fossil fuels. Of course, with any powerful technology, safety and responsible waste management are crucial. We need to ensure that nuclear power plants are operated safely and that nuclear waste is handled and disposed of properly. With the right precautions and ongoing research, uranium can play a significant role in creating a cleaner, more sustainable energy future. Section 9. Quantum Quests. Uranium's role in the next frontier. Hold on tight, science fans, because we're about to enter the mind-boggling world of quantum mechanics. Believe it or not, uranium is poised to play a role in this exciting frontier of scientific discovery. Quantum computers, which harness the bizarre laws of quantum mechanics, have the potential to revolutionize fields like medicine, material science, and artificial intelligence. And guess what? Uranium might be a key ingredient in making these futuristic machines a reality. Researchers are exploring the use of uranium-based materials in quantum computers. These materials possess unique quantum properties that could be harnessed to create more powerful and efficient quantum bits, or qubits, the building blocks of quantum computers. It's still early days, but the potential is enormous. Uranium could help unlock the power of quantum computing and usher in a new era of technological advancement. It's like having a key to a universe of possibilities waiting to be explored. Section 10. Dispelling the myths, embracing the facts. We've come a long way on our journey through the world of uranium. We've busted myths, explored its surprising abundance, and uncovered its diverse applications in energy, medicine, technology, and beyond. It's time to ditch the outdated fears and embrace the facts. Uranium is a powerful element with the potential to benefit humanity in countless ways. It's not just about bombs and hazards, it's about clean energy, life-saving treatments, cutting-edge technologies, and unraveling the mysteries of our universe. Like any powerful tool, uranium must be handled responsibly. We need continued research, stringent safety protocols, and a commitment to ethical use. With careful stewardship, this often misunderstood element can help us create a brighter future for generations to come. Section 11. A call to curiosity. Explore the wonders of uranium. As we conclude our uranium adventure, I encourage you to keep your curiosity alive. Don't let fear or misinformation hold you back from exploring the wonders of this fascinating element. Read more, ask questions, and challenge your assumptions. The more you learn about uranium, the more you'll appreciate its complexity and potential. It's a reminder that the world is full of surprises, and even the most intimidating substances can hold the key to a brighter future. So, go forth, fellow science enthusiasts, and embrace the world with open minds and a thirst for knowledge. The journey of discovery is just beginning.